Hi students, this is a lesson on quadratic roots. So at this point you should know that a quadratic means that the equation has a second power, right? So there would be a squared term. And the quadratic roots are the x coordinates of the points where the parabola touches or crosses or intercepts the x-axis. So you may already be familiar with what these are. They are also called, they have some other names besides roots. They are called the zeros because it's when the y is equal to 0. So when the value of the function is equal to 0. So I'll make a little note down here. Y is 0, not 1, 0, all right? And they are also called the x-intercepts, which you can probably tell why from my definition above, because they are the places where it intercepts the x-axis, and they are also called solutions. So when we have been solving quadratics, those values that we find when we solve, if we make a graph, they are the places where the function crosses the x-axis. And so there are many ways that these could go, but I'll give you a couple examples for each of what the parabola might look like. For instance, if it has two solutions. If it has two solutions, it could look like this. Okay. It could look like this. Notice both of those cross the x-axis in two places. There could be just one solution. With one solution, what that means is that that vertex is on the x-axis. So that one little point is the only place where it touches. It could be touching and going up. It could also be touching but going down, and the maximum of that would be our one solution. So it is intended to actually be touching there. And then you can actually have quadratics that we can graph, but they have no solution, no real solutions. And that's because they never touch the x-axis. So maybe like this, maybe like that. All right, so maybe the minimum is above the x-axis or the maximum is below the x-axis, and it actually just never crosses the x-axis. And so that's what, when we were doing quadratic formula, if we got things like no solution or no real solutions, imaginary solutions, that's because they don't cross the x-axis. All right, so we'll give you some examples here, and we'll go from there. All right, let's take a look at a couple of graphs here and see what we can find. All right, so in this case, we are trying to find the solutions by graphing. I completely realize that you might be able to do it faster by factoring. So I'm just going to put that out there, and if you can factor, that is still a legitimate way to find the zeros, and you could potentially use that to create your graph. But since this says by graphing, I am going to do it with graphing and show you that sometimes it's more work than others. So in this first one, if I was going to graph this parabola, the first thing I would do, since it's in standard form, is find my axis of symmetry. And so this would be x is -4 over 2. So x then is -2 is my axis of symmetry. So then x is -2. I'll just do this. That's my axis of symmetry. There we go. And now I can find my vertex, of course, by plugging in -2. When I plug in -2 to each of the x's, which we had some practice with this before, -2 squared, of course, becomes 4. 4 times -2 is -8, and then -5. 4 minus 13 is -9. So I am starting pretty far down on this graph, which means it's going to take a while for it to get up for me to find my 0. So I can proceed to -1, but it's probably not going to get there that quickly. So maybe I skip over to using 0, right? I don't want to get too far away. So if I use 0, of course, 0 squared plus 4 times 0 minus 5 is just going to be -5, a nice easy one. So at 0, so on the y-axis, 1, 2, 3, 4, -5, but we still are not up there yet. And then I'm going to try 1. So 1 squared is 1, of course. 4 times 1 minus 5. What do you know? 1 plus 4 minus 5 is 0. Hoo-hoo-hoo. Ding, ding, ding. We have a winner. We have a winner now. So 1, 0. 1 and 0. Oh, I gotta get my eyes adjusted. 1, 0 is here. And then keep in mind that that is 3 spaces. So I can kind of fill this out, right? That is 3 spaces. I'm not gonna fill in this whole table. I'm gonna use my symmetry to help me out. That 0, right, that solution, that root, is 3 spaces to the right of the axis of symmetry. So we're going to go 3 spaces to the left. So 1, 2, 3 would be our other 0. Now I can, if I want my graph to look better, I can also fill in this other dot. But I really am concerned with these two. And so over here at the side, when it asks us for the solution for number 1, our solutions are x equals 1 and x equal -5, right? 3 spots to the left of -2, -5. So especially if you also did -1, you may have made a few points before you found the one where the y is actually 0. Notice that if you factored, you'll say, why would I not do that first then? I know they would both have an x, and then if you like to use the little x, what multiplies to be -5 and adds up to 4? Different signs, right? It would be 5 and 4. The 5 would be with the plus. Not 5 and 4, 5 and 1, my bad. 5 and -1, but then when we solve and set them equal to 0, this would be -5, this would be +1. You do not have to do that, but just showing you. And you can, of course, add your -5, 0 point to your table, but as long as you have identified it as a solution to the side, you're fine. So you do not need to fill out every line in the table. So in the next one, number 2, again, -b over 2a So in this case, b is negative, so it's going to become positive, and 2 times 1 is 2. So my axis of symmetry is at x is equal to 1. So x is equal to 1. There's my axis of symmetry. So my first point I'm going to find is going to be my vertex. So I'm going to put in 1, and I get 1 squared minus 2 plus 1. And that makes 0. And hey, this time we are lucky because that very first point, since it's heading up, right, even without making more points, I know that this is going this way. I did not make sure that it's going through actual points because remember the goal of this was just to identify the roots. I don't need a perfect graph. And the only root here is going to be that x is equal to 1. Now, if you want to make a better, more accurate graph, of course you can. It would actually be here and then here. So I got a little wide. But notice it's still, even if I have more precise points, it is only touching the x in that one place. So if your vertex is on the x-axis, that's going to be your only solution or your only root. All right, we're going to do one more for practice that actually opens down and has a maximum instead of a minimum. Okay, number 3. For number 3. So negative b over 2a again. So this would be negative 2 over negative 2. So x is positive 1. X is 1 again. So negative 1 squared plus 2 times 1 minus 3. And again, maybe some of this you just kind of do in your head or on your calculator for that matter. Notice this is not negative 1 squared. It's 1 squared, then make it negative. So that is still negative 1. All right, so now I have negative 4 and 2. So I have negative 2. So 1, negative 2. Oh, and my axis of symmetry is at 1. Once again, popular spot for it to be, I guess. All right, we're heading down this time. So 1, negative 2, positive 1, negative 2. I have to zoom out to be able to see the x and y axis are not particularly darker on these graphs to be able to see that easily. I apologize for that. All right, so then I'm going to try, I like to go, typically I go to the right, but 0 is always a good one if it's close. Just because if I put in 0, I know that this is just going to be negative 3, which is heading in the wrong direction. Right? Doesn't seem like we're going anywhere. And so what does that tell us? Well, we're already below, right? We're already below, and this is heading down. So do I need to keep doing more points? No. If my vertex is below the y-axis, or the x-axis, sorry, if my I'm already below and I'm heading down, I'm never going to touch that x-axis. So this one we would say that there are no real solutions or no roots. Okay? All right, so you have a pretty short assignment. There are 4 questions, and then at the top of these notes will be helpful to give those 4 bullet points for the points where it intersects the x-axis. 3 of them were in the list, and 1 of them is the title of the lesson. All right, great job. Thanks.